Okay, here I'm going to work out the review for you. The first section is graphing. These are non-calculator questions. Starting off with a fairly straightforward graph. Y equals 3 to the x. Some of y'all on previous tests, when you were graphing, you just tried to straight up memorize everything, and you weren't really thinking about what graphing is or what you're supposed to be doing. Don't forget that if you can't memorize what the graph looks like, you always have the option of generating just the good old-fashioned XY table. If I plug in, say, 0 for x, 3 to the 0 power, because y is 3 to the x, 3 to the 0 power is 1, so I'll plot the point 0, 1. If I plug in 1 for x, 3 to the first is 3, so 1, 3. If I plug in 2 for x, 3 squared is 9, so I'll plot 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that tells me what's happening on the right side of the y-axis. Let's plug in negative 1. 3 to the negative first, it's 1/3. So if I plug in negative 1 for x, right here, I got 1/3, which is just going to be about right there. And if I plug in negative 2, 3 to the negative 2 is 1/3 squared, which is 1/9. So when I plug in negative 2, I go up to 1/9, which is just really, really close to the x-axis. And those points are good enough. What you do need to remember is that your exponential functions do have a horizontal asymptote on the x-axis. So make sure you get that asymptote in there, and then my graph, it will hover along the asymptote over here on the left side, and then it'll slowly start to come up. And then once you cross the y-axis, this thing takes off very fast. So it's going to come across, hit that point, then it's going to go up even steeper, and it's going to go really crazy steep. So there's your graph of y equals 3 to the x. Let's try another one, 2 to the x plus 1 minus 5. Okay, now if you have a number to the x power, that means we're dealing with exponential functions. And this one, my parent function, always identify what the parent function is because there are some transformations here. I'm starting with just the graph of 2 to the x. And with any transformation, I always list just some normal ordered pairs first. So for exponential functions, you need to know that the general shape of an exponential function is like this. And I just need a few points to get me in the right spot exactly. So I like to plug in negative 1, 0, and 1 for my x's. 2 to the negative first power is 1/2. 2 to the 0 power is 1, and 2 to the first power is 2. So when I'm graphing this function, I'm going to start with those 3 points, and then we identify the transformations. So let's see. So I'm going to start with 0, 1, 1, 2, and negative 1, 1/2. And this is what my graph is going to look like at the beginning. It's going to hover along that horizontal asymptote, and then it's going to take off. And I have this one dotted, but it's going to look something like that. Then my transformations, we need to identify what the transformations are, because what I just graphed is simply y equals 2 to the x. I need to graph 2 to the x plus 1 minus 5. I see plus 1, and that plus 1 is up there with my x, so that's going to be a shift to the left 1. So I'm going to take every point and move left 1. And then I see that minus 5, and that minus 5 is a shift down 5 units. And so we're going to do that to each point. We're going to go left 1 and down 5. So I'm going to find each point, go left 1 and down 2, 3, 4, 5. And plot the new point. Left, down 2, 3, 4, 5. Left 1, down 2, 3, 4, 5. And then the last thing you need to make sure you get is the horizontal asymptote. There was one originally on the x-axis. And when I shift, I need to move the asymptote also. So shifting left 1 isn't going to make a difference. But shifting down 5, 1, 2, 3, 4, 5, my horizontal asymptote moves way down here. And your graph looks like this. So there's what the new graph is going to look like. Right? I'll make that a little bit bolder so you can see it better. There. That's the new graph. Y equals 2 to the x plus 1 all minus 5. right, and then there's one more. This one's an e base. It's -2 e to the x minus 3 plus 1. Let's list the transformations and identify the parent function. I see 3 transformations. I see this -2, I see the x minus 3, and I see that plus 1. We have to identify what those transformations are. The easy ones to me are the shifts. I see up there with the x in that exponent, x minus 3. That means I'm going to shift to the right 3 units. And then I see x, or plus 1, that's outside. That's going to be a shift up 1. And then my -2, and the reason I started from the bottom, remember shifts always go at the bottom, the -2 is times the whole function, and it is not inside with the x. If the transformation's not in with the x up in the exponent, then it changes the y's. So I'm going to do -2 times my y coordinates. So those are my transformations, and now we have to identify the parent function, which in this case, if you stripped those 3 transformations away, you're left with just e to the x. And remember that e is approximately 2.7. E is approximately 2.7, and that's good enough. We're just going to kind of eyeball that. And I'll plug in my 3 points, -1, 0, and 1. So when I plug in -1, that's e to the -1. That's 1 over e. And e is about 2.7. So -1, or 1 over 2.7. And that's kind of close to 1/3. I mean, I can eyeball that on the graph. It doesn't have to be exact. E to the 0 is 1. That's pretty easy. Anything to the 0 power is 1. And e to the first is e. But e is about 2.7, so we're going to graph it about 2.7. And then we need to double our y coordinates. So -2 times the y coordinates actually multiplied by -2. My x stays the same, and I'm going to multiply my y's by -2. Now I told you this is on the non-graphing calculator part. If you want to bring in like a scientific calculator or something like that to help with this multiplication, I'm okay with that. This is going to be -1, and 1 over 2.7 times 2 is 2 over 2.7. And I will allow you to punch that in a simple calculator to get that out. And when you punch that in the calculator, you get -1 and about 0.7. So 2 divided by 2.7, or 1 over 2.7 times 2. I'll mostly multiply by -2, so that's going to be -0.7. 0, 1, 0, and then 1 times -2 is -2. Multiplying the y's by -2. 2.7 times 2 is about 5.4, but when you multiply by negative, that's -5.4. And those are going to be my first points. And then, so I've already done this part. I've multiplied my y's by -2. Then we're going to go up 1 and right 3. So let's get that graph going. Okay. So let's see. I'm starting with -1, -0.7, -1, -0.7. But then I need to go up 1 and right 3. So up 1 and right to 3. Okay, and then 0, -2, 0, -2, up 1, right to 3, and 1, -5.4, 1, -1, 2, 3, 4, 5.4. So I'm starting about here, but then I need to go up 1, and right 3, 1, 2, 3. And those are my 3 points, and don't forget about the horizontal asymptote. So my original horizontal asymptote before any transformations is always on the x-axis. And then I think about my shifts. Multiplying the y's doesn't change the asymptote, it's the shift. So I need to go up 1 and right 3, so I'm going to take this asymptote, go up 1. And if I move it right 3, it's not going to make a difference. So my asymptote is now right here. And that's enough to help me see what this graph is doing. This one's actually flipped upside down. I'm going to hover on my asymptote, and then once I get to my points, it's like I'm going to drop off the table. So I'm going to sit up here, then I'm going to start to hit my points, and then I'll fall down. So there's our graph for number 3.